Hello friends, welcome back to CSharp.net online training video series. Today we are going to discuss one of the important concept, that is exception handling. As a developer, it is our key responsibility to handle exception which might be occurred at runtime. That means as a developer, while developing any kind of application, right? Whether you develop any web application or any desktop application or any APIs, right? Then it is our key responsibility to handle the exception. If we are not handling our exception, means we will face problem in the future, right? So exception handling is a procedure to handle the exception which occurred during the execution of a program. That means while we are running our application, if some kind of a runtime error occur, then exception handling is a mechanism to handle those runtime errors, right? So that is what how to handle those runtime errors, how the runtime error are occurred, right? Those things we are going to discuss in today's video. So what we are going to discuss in today's video? First, we will start the discussion with the different types of error, and then we will understand that there are two types of error. One is compilation time error, and one is runtime errors, right? Then we will discuss what is exception, right? And once we discuss what exactly exception, then we will discuss who is responsible for abnormal termination of the program whenever some runtime error occur during the execution of a program. Once we discuss who is responsible, then we will discuss what happens if an exception is raised in the program. Then we will discuss what exactly CLR does when an exception occurred in the program. Then we will discuss what is exception handling in C#, right? Then we will discuss why we need exception handling, right? And then we will discuss what is the procedure to handle an exception. We'll discuss here. We will discuss there are two approaches to handle exception. One is logical implementation and one is try catch implementation, right? So we will discuss how to handle exception using logical implementation. We will see what are the things we can do with logical implementation, what are the things we cannot do with logical implementation, and then we will see how we can do those things by using the try catch implementation. And then we'll discuss one of the important class, right? That is exception class, which is nothing but the super class of all exception classes in C#, right? We'll discuss what are the methods and what are the properties available in this class. And with this, we will conclude today's session. Let's start today's session. What are the different types of errors we can come across while developing our application? Generally, whenever we are working with any kind of application, we came across with two types of errors. What are these? The compilation error and the runtime error. What are compilation error? Let us see the definition. The error that occurs in a program at the time of compilation is known as compilation error, or you can say compile time error. This error occurs due to syntactical mistake in the program. Syntactical mistake means this error are occur by typing the wrong syntax, like missing double quotes in the string value, missing terminator in a statement, typing wrong spelling for keyword, assigning wrong data to a variable, right? Trying to create an object for an abstract class interface. So whenever we compile the program, the compiler recognizes this error and it will show us the list of error. For example, right? So in this case, in static, if I miss 80, then we'll get one error because it is a wrong syntax. That means you have to write static, right? For example, if I'm creating a string variable str, right? String means it should be ended with a double quote. If I'm not providing double quote, then it's going to be a syntactical error. And if you are missing the semicolon, right, at the end of the statement, then also it is going to be a runtime. It is going to be a compile time error. And this compile time error are will come to know at the time of program compilation. See, while developing, the compiler itself showing, the Visual Studio itself showing that there is some error. And even though when we are compiling the program, the list of compilation error we can see in the error list window, right? So these error are not that harmful because we can understand the error right easily, and we can fix the error before executing the program. And why this error occurred means because of the poor understanding of the programming language. If you do not know exactly the syntax, the rules and regulation of the programming language, then will face this error. Because if you don't know whether if I'm going to declare a static method, means I need to use the static keyword. And if you do not know there is a static keyword, then how you can define the static method? If you do not know if you are creating a variable of string type, means it should be enclosed with double quotes, then how you can develop this? And if you do not know each and every statement should end with a semicolon, then it's nothing but your poor understanding of the programming language, right? And these errors are identified by the compiler and can be rectified before the execution of the program only, right? So we can identify, or compiler can give you the list what are the compilation error in your application, so that you can easily rectify and easily fix, and you can run the application before once you fix the error, then you can run the application. So this error do not cause any kind of harm to our program execution. Now comes to runtime error. The errors which are occurred at the time of program execution are called runtime error. This error occurred at runtime due to various reasons, such as when we are entering the wrong data into a variable. For example, you declared one integer type variable, but while entering the data from the keyboard, you are putting some string value like ABC. So you cannot store string data into integer variable. So this is nothing but one runtime error. Trying to open a file for which there is no permission, right? You are trying to read the data from a file, but you do not have permission to read the data, right? Trying to connect to a database with the wrong user and a password, right? So you are so while connecting with the database, for example, you are trying to connect the SQL Server database. For connecting, you are using SQL authentication, right? And while you are using SQL authentication, it is mandated to provide the username and password and the IP address of the server. And if you are providing any wrong information, then you will get some kind of a runtime error. Wrong implementation of the logic. For example, in your application, you know that you cannot divide one integer number with integer zero, but in your application, if you are implementing that divide by zero logic, then it is nothing but your wrong implementation. And for that wrong implementation logic, you will get runtime error. Missing required resources. For example, today you develop one application, right? And in that application, you are reading the data from a text file, right? And today that application is working fine, but after 1 week, by mistake, by accidentally, or by unknowingly, if someone delete that text file, and after 1 week you are trying to run the application again, then you will get this missing required resources runtime error. So in simple words, we can say that the errors which are come while running the program are called runtime error. And runtime errors are dangerous because whenever they occur in the program execution terminate abnormally on the same line where the error gets occur without executing the next line of code. For example, what I'm saying, now I'm creating one integer variable with the value 10. I'm creating y variable with the value 0. And what I'm trying to do is I'm creating another variable result. And here I'm doing a arithmetic division operation, x divided by y, right? And then I'm printing the value of the result variable, right? Console dot write line, and I'm printing the value of the result variable. So in this case, right? In this case, the compiler will never going to check the business logic. What logic you have written, that compiler is never going to check. What compiler will check? Compiler will check the syntax. Whether you are writing the syntax properly or not, whether you are ending the statement with a semicolon, whether you are using the keyword properly or not, whether you are storing the proper data in the variable or not, those things are going to be checked by the compiler. But what logic you have written, that logic is never going to be checked by the compiler. Then at runtime, when we run this application, you will see that at this line number 9, we'll get some exception. We will get some error, right? Runtime error. And when the runtime error occurred, the program execution terminated abnormally. Abnormal means the program execution terminated here, and the program is not going to be the CLR is never going to be executed the next statement which are present after the runtime error causing statement. So in this case, once you run the application, you will see that the line number 9 is going to give you some runtime error, and at that line number 9 only your program execution terminated. And after terminating this program means the statement which are present after the runtime error statement is never going to be executed. So these two statements are never going to be executed, right? Now if you click on the continue button, then you will see that the program execution completed, right? So this is the thing that you need to remember. The compiler will never check the logic. The compiler will check only the syntaxes. So the compiler will identify the syntactical error, but not the logical error. Now, each runtime errors are dangerous. Yes, runtime errors are dangerous. For example, suppose you are transferring money, right? You are transferring money to your friend's account, right? Then this money transferring is nothing but, let's assume, behind the scene, two update statement are executed. One update statement will deduct the money from your account, and another update statement will add the money to your friend's account. Suppose first update statement is executed. That means money is deducted from your account, but before executing the second update statement, some problem occurred, some runtime error occurred. That means the second update statement is not executed. That means what? That means the money is deducted from your account, but the money is not added to your friend's account. Then what you will do? Right? You might be contacted with the bank. You might be going to the nearest branch and investigating what happens. Why the money is deducted from my account? Why it is not added to my friend's account? This is the problem, and this is very dangerous, right? And this is because we are not handling runtime errors in our application. If we handle the runtime error properly, then the money is not going to be deducted from the sender's account, right? So we need to handle in such a way that we need to make sure if money is deducted and if some error occur, then we need to reverse the things, right? We need to reverse the money what is deducted from the sender's account. But this is possible if we are handling the exception, and this is not possible if we are not handling the exception, right? So this is the reason you know how important exception handling concept is, right? Now let us understand what is an exception. An exception is a class in CSharp which is responsible for abnormal termination of the program when runtime error occurred while running the program. So these errors are very dangerous because whenever this error occurred, the program gets terminated abnormally on the same line where the error gets occurred without executing the next line of code. So what is exception? Exception technically, if we speak, it is a class. And what is the use of this class? Now, in this case, suppose we are doing some kind of a logic, right? Here we are doing some kind of a logical mistake. And the CLR came to know that this is a logical mistake the user is doing. Then what CLR will do at this statement is, he will first figure out what logical mistake is this. Yes, the CLR figure out that this is a divide by zero logical mistake. Then second, what CLR will do then the CLR will check whether is there any exception classes available to handle these things. Yes, one exception class is available. What is that exception class? Divide by zero exception class. Then the once he identified that this logical mistake is associated with divide by zero exception class, then he will create an instance of divide by zero exception class, right? Once he create an instance of a divide by zero exception class, then he will throw that exception here by using the throw statement. That means that exception class is basically to handle to basically abnormally terminate the program. Whenever the runtime error occur, the CLR will take help from of the exception classes to terminate the program abnormally, right? So this is the thing that you need to understand. Exception are nothing but classes, and they are responsible for abnormal termination of the program. In this case, what you can see, instead of this statement, what exactly compiler do? Compiler will write this throw statement, then it will write new divide by zero exception, right? So in this case, you can see if I'm running this application without using this, then you will see that we will get some divide by zero exception, right? So now the application is running, right? Yeah, so you can see divide by zero exception. So this is nothing but your exception class. And the CLR, right? CLR will create an instance of this class and then throw that instance. How the CLR creating and throwing that instance? By using this statement. Now if you look at this statement, now I'm commenting this statement, right? Now you can see, right? Okay, stop. Now you can see I'm writing this statement, throw new divide by zero exception. The same exception what we got in our previous case, we'll get the same exception again. System divide by zero exception, right? So what exactly, this is your logical mistake, but for this logical mistake, CLR will create an instance of one of the exception classes which is related to this logical mistake, and once it create an instance, then it will throw that instance. And once it throw that instance means the method execution, right, is going to be completed here, right? Completed in the sense from here onwards, the rest of the method are never going to be executed, right? This is nothing but abnormal termination. right? Abnormal termination means the method execution is not terminated or not completed in a normal manner. It is completed in an abnormal manner. Why abnormal manner? Because the statement which we supposed to execute after the exception causing statement are not executed. So in this case, these two statements are not going to be executed. I hope you understand this concept, right? Most of the people are saying runtime error or exception, which is not true. Exception are classes that are responsible for abnormal termination of the program when runtime error occurs, right? Now, who is responsible for the abnormal termination of the program whenever runtime error occurs? Object of exception classes. So in this case, we are creating an object of exception class. Here, the exception class is divided by 0 exception. So object of exception classes are responsible for abnormal termination of the program whenever runtime error occurs. These exception classes are predefined under VCL, where a separate class is provided for each and every different type of exception. For example, you are creating an array. If you are creating an integer array with size 5, and you are okay, let me give you the example directly so that you can understand this. So I'm creating an integer array, ARR with 5 elements. Okay, let me, yeah, 1, 2, 3 elements, right? And then what I'm trying to do, I'm creating one for loop, right? For integer I equals to 0 and I less than, I'm trying to access, I5, right? I plus plus. So in this case, if you, okay, let me print the value of the array, control the right line, and I'm typing ARR of I. So first of all, you just tell me how many elements are there in the array? 3. That means the array size is 3, and the array index is going to be from 0, 1, and 2. And here we are trying to access the array element from 0, 1, 2, then 3 and 4 as well. So whenever I'm trying to access the array whose index is 3, at that time we will get one runtime error. Why? Because there is no such index available inside this array. So this is nothing but, you can say, what error? This is index out of range exception. So now I'm running the application. You can say index out of range exception. Index was outside of the bound of the array. So this is one of the error, right? So this error, you know, you are trying to access an index of an array which is not exist. So compiler check, yes, this is the error, and this logical mistake is associated with this exception class. Let me create an exception of this. Let me create an object of this exception class, and once the CLR create an instance of this exception class, then we will throw that instance, right? So this is nothing but your index out of bound exception, format exception. For example, let me explain you this also. So I'm asking the user, right? I'm asking the user to enter a number, right? So please enter a number. And we know how to enter a number, right? So what I'm trying to do, I'm taking this integer number equals to convert dot to int 32, and here I need to write console dot read line, right? Console dot read line, right? So here I'm taking the input and I'm converting that to a number. But what I'm doing now, instead of entering a number, I'm going to enter a string value. Then the string cannot be converted to integer. Suppose here I'm writing hello, right? So if I'm writing hello, then you will see that format exception is there, because you are trying to enter a number which cannot be converted to this format, right? So as you are entering a value which cannot be converted to that particular format, so you will get format exception, right? That means the point that you need to remember, for each kind of logical mistake what you done in your application, there is a separate class available. Like this, null reference exception, divide by 0 exception, file not found exception, SQL exception, overflow exception, right? There are so many exception classes are available, and each exception class is specifically designed for a specific exception message, right? So each exception class provide a specific exception error message, right? All the exception classes are responsible for abnormal termination of the program, as well as they will be displaying an error message which specify the reason for the abnormal termination, right? In this case, you can see they are displaying one message, right? So they are giving one message. What message? Input string was not in a correct format. This message they are saying, and this message specifically designed for this kind of error message, right? That is the point that you need to remember. So whenever a runtime error occur in a program, first the exception manager. Who is the exception manager? Now it is a component under the CLR. CLR we already discussed. There are many components available inside the CLR, and one of the component is exception manager, who identify the type of error that occur in the program. So in this program, if what type of error, it is this, right? It is a file format exception, right? We cannot convert that value to a integer number. So once he identify the type of error, then he creates an object of the exception class, right? Exception class means it is a format exception. So he will create an instance of a format exception, right? And that exception class should be related to that particular error, and then throws that error, which will immediately terminate the program execution on the line where error got occurred. So in this case, in this line only you will throw the error, and the rest statement what you have written after this line, they are never going to be executed. So this is the point that you need to remember. And what is exception? Exception is nothing but it is also a class, and you can consider this is the super class of all these exception classes. So these classes you can see are child classes of this exception class. So he is the parent or super class of all .NET exception classes. What happens if an exception is raised in the program? We have already discussed. When an exception is raised in the program execution terminated abnormally. What it means? It means the statement placed after the exception causing statement are not executed, but the statements, in this case, this console.readline statement is not going to be executed, but statement which are present before the exception causing statement, they are going to be executed. In this statement, we are getting this error, but if you remember, that statement is also whatever previously they are enter a number, we just entered a message. Those are already executed. That means the exception causing statement, what will do now, what runtime exception will do, the statement which are present before the exception causing statement, that are going to be executed, but the statement which are present after the exception causing statement, that are never going to be executed, right? What CLR does when an exception occurred in the program? The CLR creates the exception class object that is associated with that logical mistake and terminates the program execution by throwing that exception. Okay, so how it will create an exception? By using the new keyword, and how it will throw that exception? By using the throw keyword. That is what we have already seen right now. Program execution without exception. Now let us see some of the example to understand the concept in detail. So in this case, if you look at this program, so what I'm trying to do, I'm creating two variable A and B, and I'm creating another variable C, and I'm just printing the A value, B value, and I'm doing one arithmetic operation, that is division operation, and then I'm printing the value of C. In this case, I'm not going to get any kind of error. Why? Because this is 20 and 10. 20 and 10, its division is possible, and once we divide, then we will get the output as expected. So in this example, I'm not going to get any kind of error. So you can see here A value 20, B value 10, and C value is 2 printed. So that is fine. Now let us do one more thing. Let us try to make the example to throw some kind of exception. So in this case, if you look at the example here, the B I'm making at 0. So once you make the second number as 0, so whenever you are dividing 20 by 0, so at this point of time, the CLR will throw an exception. How it will throw an exception? It will create an instance of the divide by 0 exception class, and once it create an instance of divide by 0 exception class, then it will throw that instance by using the throw keyword, right? That is what we have already seen, right? So but remember when it will throwing the exception means, if you look at the message, right, so A value equals to 20, B value equals to 0, that means up to line number 12 the print statement are printed. Line number 13, the exception causing statement. So from this statement, the program execution terminate abnormally, and this statement are never going to be executed. This is the point that you need to remember, right? Right. So what is the above exception message is user understandable? Suppose I'm running this application, right? Is this exception message system dot divide by 0 exception attempted to divide by 0, right? Is this message user understandable? No. this message is not user understandable, right? Why? Because this message, what the seller is throwing, it is .NET based messages. These are .NET based messages. So the user cannot take any decision alone to resolve the above problem. A developer should guide the user to solve the problem. So if we are getting this kind of error, then if we are a normal user, if we are not a developer, then we cannot resolve this issue. Then what we need to do? We need to take the help of a developer. The developer will guide us and the developer will resolve the issue, right? So what is the solution? The solution is we need to convert this .NET based exception message to user understandable message, right? So what is the solution? It is the developer responsibility to convert the .NET exception message into user understandable message format, right? To solve this problem, developer should handle the exception. Using the exception handling mechanism, the developer can catch the exception and can print and display user understandable messages. What is exception handling, right? The process of catching the exception for converting the CLR given exception message, or you can say the process of converting the .NET based message to end user understandable message, as well as for stopping the abnormal termination of the program when the runtime error occurred, is nothing but exception handling. Simply speaking, what is exception handling means? The process of handling, right? The process of converting this .NET based message, or what CLR message provide was the process of converting this message to a user understandable message, as well as to stop the abnormal termination of the program. Abnormal termination of the program means we should not stop the program execution here. We need to continue our program execution, right? And if we want to achieve these two things, right, the process we can handle this in our CSharp programming language is nothing but exception handling, right? So once we handle exception under a program, then we will get the following advantages, right? What are the advantages? We can stop our normal termination. Now the program is not going to be stopped here. It will continue its execution. We can perform any correction action that may resolve the problem, right? If possible, then we will ask the user, hey, Mr. User, don't enter the second number as 0. Please enter something else, so that he can take the he can resolve the problem and he can continue this application, right? So displaying a user-friendly error message, right? So if we provide a user-friendly error message so that a user can resolve the problem by his own, right? It is under his control. It is not possible that always the user can resolve the problem, but if the solution is under his control, then he can resolve the problem. If the solution is not under his control, then as a developer, we need to check, right? So why do we need exception handling means? Because of the two reasons. What are the reasons? Now to stop abnormal termination of the program and to provide user understandable message whenever an exception occurs, so that the user can take any so that user can take decision, or the user can resolve the problem without a developer's help, right? So basically, by implementing exception handling, we are providing life to a program to talk to the user on behalf of a developer, right? If we are implementing the exception handling properly, then without take the developer help, the user can talk to the program. So what is the procedure to handle exception? Okay, the procedure to handle exception is composed of 4 steps. What are the steps? First, we need to prepare the exception object that is appropriate to the current logical mistake. Suppose in this example, first of all, we need to identify what is the issue. The issue is divide by 0. So create an instance of divide by 0 class, divide by 0 exception class. Throw that exception to the appropriate exception handler. Once we prepare the instance, then what we need to do? We need to throw that instance. How we will throw? By using the throw cat. Then the third step, we need to catch the exception. We should have some catch block, right? And that catch block is going to catch the exception which thrown by the CLR using the throw keyword. And once we catch the exception, then we will take necessary action to resolve that exception, or to some action against that exception, right? Now, how many ways we can handle exception in C#? Right? So people are start implementing try-catch, right? But before try-catch, we need to understand what is logical implementation. So in C#, we can handle one exception in 2 ways. One is logical implementation and another one is try-catch implementation. What is logical implementation? See, in logical implementation, we need to handle the exception by using a logical statement. What is logical statement? If else statement, right? And in real-time programming, the first and foremost importance is always given to logical implementation only, right? If you can handle the scenario, if you can handle the cases by using if else conditional statement, then please use if else conditional statement. And if it is not possible to handle the exception using the if else conditional statement or logical statement, then only you need to go for try catch implementation, right? But always we need to give priority to logical implementation, right? So let us see one example to understand how logical implementation can be implemented in our application, right? So see, here I'm declaring three variables, number one, number two, and number is result, right? Then I'm asking the user to enter the first number, the end user entering the first number, and I'm storing that number in this variable, right? Now again, I'm asking the user to enter the second number, the user entering the second number, and I'm storing that inside the number two. Now I'm checking if number two equals to zero. If the user entered the second number as zero, then display this message. Second number should not be zero. And if second number is not zero, then perform the division operation and show the result now. Now, if you run this application, right? Now I'm running the application, right? So first output, what I'm trying to do, I'm trying to enter the first number as 10, second number as 5. So once I do this, I will get the result as expected result 2. Now, second time I'm running the application, and in this time, I'm giving the second number as 0. So as I'm providing the second number as 0, I'm not getting any kind of exception. What I'm getting one message, second number should not be 0. That means this message I'm providing to the user. Now the user can see this message and the user can take action. Yes, what wrong I'm doing? Yes, I'm entering the second number as 0. So I need to fix this. Right. So this is how you can implement logical implementation to handle this error. But if we can handle the things using logical implementation, then why try-catch implementation is there? Yes, try-catch implementation is also important. Why? Now, if it is not possible to handle some exception using logical implementation, then how you can handle? Now, in that scenario, you need to go for try-catch implementation. How? See, in this example, what I'm trying to do, I'm entering the first number as 10, and in the second case, I'm entering ABC. And when I'm entering the second number as ABC, then this cannot be handled by using your logical implementation, right? So this is, you can see immediately I enter the second number, I got an exception. So if, and this is not possible to handle using your EPLs or your logical implementation. So to handle this scenario, right, which is not possible to handle by using logical implementation, you need to go for try-catch implementation, right? Right. So how to handle exception using try-catch implementation, right? The try-catch implementation you can handle by using three keywords. So .NET Framework provided three keywords to implement try-catch implementation. What are these? Try, catch, and finally. What is the use of a try block? The try block establishes a block. The try keyword establishes a block in which we need to write the exception causing and its related statement. Right, the statement which causes the exception, right, and the statement which you do not want to execute when a exception occurred, you need to put those statements inside the try block, right? When the exception occurred, the CLR will create an instance of the exception class based on the logical error, and then throw that exception object which is going to be handled by the corresponding catch block. So these the things that are going to be happen inside the try block. So the statement and the related statement which you do not want to execute whenever the exception occurred, you need to put inside the try block, and whenever some exception occurred, the CLR will create an instance based on the logical mistake you have done in your code, and once he create an instance, then he will throw that instance, right? And then that instance is going to be handled by the corresponding catch block. Now the catch block is used, right? The catch block is used to catch the exception that is thrown from its corresponding try block, right? If the try block throwing one exception, then that exception is going to be catched by the catch block. It has the logic to take necessary action on that code exception. The catch block syntax is very similar to the constructor, means it doesn't have any access modifier, normal modifier, or return type. You cannot write a public catch block, or you cannot write a public int, right? No return type, no modifier, right? No accessibility modifier. It takes only a single parameter that is of an exception type. or any child class of the exception type. So exception type means if you are creating one catch block, you can pass exception as a parameter, or any child class whose parent is exception, you can also pass that as a parameter. Inside the catch block, we can write any statement which is legal in .NET, including raising an exception. Even though from the catch block, you can also throw an exception. That is also possible. In our coming video, we will also discuss that case, right? In this case, we can stop the abnormal termination of the program, and we can also give user understandable error messages. So once the controller comes to the catch block, then the abnormal termination is not there. So whatever statement you want, you can print whatever statement you want to execute, you can also execute. And after executing the catch block, then the followed statement are also going to be executed. And what is this finally block means? The keyword finally establish a block that definitely execute the statement placed in it, irrespective whether any exception occurred or not. Suppose you are implementing try catch and finally, right? First of all, the try block is going to be executed. If there is no exception, then no catch block is going to be executed, but finally block definitely going to be executed, right? So you are executing the try block, some exception occurred, catch block is going to be executed. After executing the catch block, then again the finally block is also going to be executed. That means the finally block give you guarantee that whatever statement placed inside it, they are 100% is going to be executed, whether your application throwing some exception or not, whether that exception is handled by the catch block or not, but 100% the final block is going to be executed. Now to understand this how the exception handling is implemented, you need to understand the syntaxes. See, this is one method, and here I'm writing the normal statement. Normal statement means this statement doesn't cause any kind of exception. Some statement like variable declaration, right? So object initialization, those statement never throw any kind of exception, so you can put them outside the try block. And when what you need to put inside the try block means the exception causing and related statement which we do not want to execute when exception occurred, right? Whenever some exception occurred, and if you want this statement to not be executed when exception occurred, then you need to put that exception causing statement as well as the related statement inside the try block. And moreover, you can have multiple catch block, and each catch block is specifically designed to handle a particular exception, right? So this is some exception one, and this statement, this catch block is going to be executed whenever the try block throws some exception one, right? If some exception one is not thrown by the try block, then this catch block is not going to be executed. Suppose the try block throw some exception two, that means the second catch block is going to be executed, right? Suppose the try block doesn't throw some exception one and some exception two, that means these two catch block is never going to be executed, and we have the generic catch block. Generic catch block means the catch block taking the exception. Exception means it is the parent class. As it is the parent class, any type of exception you throw, that is going to be handled by this catch block, right? So if none of the catch block in the above list is executed, then definitely this catch block is going to be executed. And after executing this catch block, you can write your normal statement, which is going to be executed after all the catch block, right? After the last catch block, right? So once we use try catch block, right, in our code, the execution takes place as follows. If all the statements under the try block are executed successfully, from the last statement of the try block, the control directly jumps to the first statement that present after all the catch block without executing the catch block. See, if there is no exception occurred means the last statement of the try block executed, then the controller directly jump to this normal statement. It is never going to execute these three catch blocks. If any of the statement in the try block causes an error from that statement without executing any other statement in the try block, the control directly jumps to the catch block which handle that exception, right? For example, in this try block, we have 5 statements. In line number 3, in statement 3, we have some error occurred. Then from that 3, right, it will not execute the statement 4th and 5th. For example, let's see, we have got some exception like some exception 1. Then from that line number 3, it will directly jump to the catch block which handle that exception. Is there any catch block which can handle some exception 1? Yes, this catch block is there which can handle this exception. So it will come to this catch block and it will execute the body of this catch block. And once it execute the body, it will not execute the rest of the catch block. Directly it will go to the normal statement which is present after the last catch block. So this is the second one. If a proper catch block is found and handle the exception thrown by the try block, then that abnormal termination stop there, executes the code under the catch block, and from there again it jumps to the first statement after all the catch block. That what we have just discussed. If a matching catch block is not found, then the generic catch block is going to be execute and handle the exception. For example, from the line number 3, you throw some exception 3, right? Some exception 3 you throw. But that some exception 3 is not handled by the first catch block, it's not handled by the second catch block, then that third catch block, what you are creating as a generic catch block, because here the exception type is exception, it can handle any type of exception. So that some exception 3 is going to be handled by this third catch block, and it is a generic catch block. And once it handled, then it will stop the abnormal termination, right? And if you want, you can give some user specific error message, right? You can print here, and after executing this statement, it will come to the normal statement which is present after all the catch block. And if you do not have the generic catch block, so for example, in your application, you have only catch block 1 and catch block 2. You do not have this generic catch block, and you are throwing some exception 3, then in that case, this catch block is not going to be executed, and this catch block is not going to be executed, then it will not execute this normal statement. Again, it is going to be a abnormal termination because no catch block is there to handle the exception, right? Here we are showing the try catch block execution. Later in our coming videos, right, we will show you how to use finally block, right? Now, example, okay, let me give you one example with generic catch block, right? So generic catch block means a catch block without any exception, right? So in this case, you can see these are the statement which might cause exception, right? It might be possible that you are entering a wrong data, you are entering a string value, right? It might be possible that you are entering a integer value whose capacity is beyond of int 32, right? And it might be possible that you are entering the second number as 0, so you will get some error. And if you are getting the error, if you are throwing some exception here, then you do not want to print this result. So this statement is related to this statement, so you do not want to execute. So these are the exception causing statement, so you need to put those statement inside the try block. Now inside the catch block, this is a generic catch block. Generic catch block means this catch block can handle any type of exception occurred in the program, whether it is a format exception, whether it is a stack overflow exception, right? Whether it is a divide by 0 exception, all the exception are going to be handled by this catch block, and it is a generic catch block. Generic catch block means catch block without any exception class. So here you can see I'm not providing any exception class, so this catch block is a generic class catch block, and this catch block can handle any type of exception. Okay, let's prove this. So let me run the application. Okay, first time what I'm going to do, I'm going to enter 10 and 0. So you can see I'm entering 10 and 0. You can see some error occur. That means that divide by 0 exception is handled by this catch block. Now what I'm trying to do, I'm entering 10 and the second number I'm entering ABC. You can see some error occur. That means the format exception is also handled by the generic catch block. Now I'm trying to enter a big integer value, right? Suppose I'm entering a big integer number which is beyond the capacity of int 32. So in this case also, that overflow exception is handled by the generic catch block, right? So the point that you need to remember, generic catch block means it can handle any type of exception. Then what is the problem? The problem is that you cannot give any specific error message in the sense why the error is occurred. Whether it is a format exception, whether it is a divide by 0 exception, or whether it is a stack overflow exception, you cannot provide specific error message, or you cannot provide a proper message why the exception is occurred, right? Every time you run, you will get the same message. This is the problem. Then how we can overcome this problem? We can overcome this problem by using the exception class, right? By using the exception class. Now, if you go to the exception class, so as I discussed, right, exception is nothing but it is the super class of all the .NET types, or all the .NET exception classes. If you go to the definition of exception class, you will see that there are lots of virtual methods and virtual properties, right? So you can see this is one exception class. This is one constructor, doesn't take any parameter. Here one parameter, here parameter, right? And you can see this is a virtual method: source, help, link, stack, trace, right, message. So these are nothing but some of the few properties. And if you remember, this method or these properties are declared as virtual, and even this is one method declared as virtual. Virtual means what? That the child classes can re-implement this method. Can re-implement not is saying wrong. The child classes of these exception classes, they have provide a different implementation. If you take the divide by zero exception, they have provided implementation for the source property. They have provided implementation for the help link property. They have provided implementation for the stack trace property. They have providing implementation for the message property. So each child exception classes, right? They are providing implementation, re-implementation for all the virtual member, right? Now if you look at this class, so few are some of the important property that we generally use while working with real-time application. One is message. This property will store the region where an exception occur, whether it is a file format exception, whether it is a divide by zero exception, the region source. This property will store the name of the application from which the exception has raised. And what is the application name? There, that will show help link. This is used to provide a link to any file or URL which will give helpful information to the user why this exception is occurred. And this is stack state. This is the most important property. This is used to provide more information about the exception, like the reason for the exception, why this exception occurred, at what method this exception occurred, at what class this exception occurred, at what line number this exception occurred. All these information are going to be provided by this stack trace, right? So this is the useful. Now let us see how we can implement this example using the exception class and how it is going to be beneficial for us comparing to the generic catch block. So in this case, I'm creating one catch block with the exception class. We can create multiple catch block. That is a separate story that we will discuss, right? How we can create multiple catch block and what is the order of all the exception classes, right? That we'll discuss in our next video, right? But for now, you can see what I'm doing. I'm creating the same example, but in this case, it is not a generic catch block. It is a specific exception catch block. And what type of parameter this catch block is taking means it is taking the super class. And if you remember this class, exception class, we have discussed few properties. You have source, help link, stack trace, message. What we have discussed, you can access all those property using this exception. Now, from here, the compiler will throw an exception, and that exception is divided by zero exception. And as divided by zero exception is a child class of this exception class, and in our inheritance video, we have discussed a parent class reference variable can hold the child class object, right? Child class instance. In this case, the child class instance is divided by zero, and in this case, the parent class is exception, right? So this is the reason why any type of exception you throw, that can be handled by this super exception class. And once it handles the exception, then it will give you us the message, what is the region, where the exception, at what application, some useful helpful link from where you will get more information about the exception. And this stack trace means where, at what line, at what method, at what class this exception or occurred. So all this information we will get. Now let me run the application. Okay, first of all, I will enter some two integer number, right? 10 and 2. And in this case, I'm not going to get any kind of exception. That means in this case, this statement is executed and there is no exception. Now second time I'm running the application, and this time I'm entering the first number as 10, the second number as 0, right? Second number as 0. And in this case, you can see I'm getting one error, attempted to divide by 0. Yes, I'm attempting a division operation by passing the second number as 0. Source means the project name. What is the project name? You can see in the right hand side, exception handling demo. So the project name is exception handling. Help link, for this exception there is no help link, so I'm not getting any kind of a message, right? The stack trace means it will give you where the error is occurred, at what line the error is occurred. So you can see the line number 15 is the error. At what class file, program.cs class file, line number 15, right? At what method, main method, right? So all the information you can see, right? This stack trace giving to us, right? Now what I'm trying to do, I'm going to run the application again, and this time I'm not passing 0, I'm passing a string value. So in this case, I'm going to get a different error. What error? Input string was not in a correct format. Source ms crow lib, right? This is the application, right? So this is the application, means the string class belongs to this microlib application. Help link, there is no help link, and this is the stack trace. What is the region where the exception occurred, at what class, what method, what line number, all the information it is giving to us. You can see line number 14 program.cs class file. Where is the line number 14? Yes, this is the line number 14. That means at this statement, I'm getting this input string was not in correct format exception. So this is how you can implement a try and exception, try and catch block. And this is a generic. You can also consider this as the generic catch block, because any type of exception that is occurred in the corresponding try block, that can be handled by this catch block, right? In our next video, we are going to discuss how we can implement multiple catch block. Reason, see, if you are not implementing multiple catch block and if you are using the super exception catch block, right, then you will get very bad performance, right? So you can see, if we use exception class and when there is a relevant child exception class is available, it will kill the execution performance of the application, right? So in this case, you can see this is the exception class. This is the parent exception class, and what exception currently we are throwing from this class, that having a child exception. What is that child exception? And that exception is format exception, right? So suppose format exception. So you can see format exception. So in this case, this format exception is available. Then why I'm going to use child exception class? If I'm using exception class, then it will give you bad performance. If I'm using format exception, then it will give you better performance. But the reason is going to be same. They are going to handle the same thing, but performance will improve if you are going with child exception classes. Now if I enter the first number as 10, right, and if I enter the second number as ABC, right, in this case, you will see that still that format exception is going to handle the exception, right? So in our next video, we are going to discuss what is the importance of different child exception, child catch blocks, not child catch block. We can say what is the advantages of creating multiple catch block with the child exception classes. That's it. In case you need the text version of this video, the link for the same is provided in the video description section. Go to that link and get the documents. Thank you. Thank you.